Welcome to the Central Water Testing Labs. It is a laboratory under the Water Resources Management Authority, which was established over 20 or 30 years ago. There are 6 laboratories under Wrma in the major regions in Kenya, that is in Mombasa, Kisumu, Nakuru, Kakamega, and we're involved in a few tests. Effluent testing for wastewater and for drinking water. For drinking water, there are 2 types of tests that we do. There are physical-chemical tests and there are biological tests. We normally do 2 types of tests. Wastewater test, that is water that is emitted, that is discharged by industries, schools, and water companies. So that water we normally measure a few parameters to ensure that they are of the correct the correct quality for discharge into the environment. And we do drinking water tests. Under drinking water tests, we do bacteriological tests and potable water tests. Bacteriological tests normally involves testing the microbial content of the water so that to avoid diseases like diarrhea and typhoid. Potable water test involves physical chemical parameters. This include pH, conductivity, fluoride, arsenic, ammonia, and such like parameters that determine the quality of water.
This machine, it's a UV spectrophotometer which uses absorbers to get the concentration of water. You can use it to measure actually most of the ions like nitrates, sulfates, nitrates. Basically, I can demonstrate for you. You put your sample in this cuvette. Then you get your readings directly from the spectrophotometer. When you get the readings, we have this table where we've come up with formulas to get the concentration, the final concentration of the ions. For example, now this is the nitrate. So here we write the sample number, then the milliliters that we used for the sample. This is 51. Then you write your readings, absorbance at 220. Then we've entered the formula, so it calculates itself, and you get now the final concentration of the ions.
After the analysis is done, we have our record books. All the analyses are entered in the record books. Now, from the record books, we enter them into our forms so that the forms are forwarded to the head of the lab for comment. have several books for analysis. Each parameter has its own record book. So we got them in our forms. The analysis according to the results after calculations. Once we are through with the recording into the forms, we have a release book. We enter all we enter all the numbers in our release book. Having so many which have been entered here, ready for releasing. After we enter all the numbers in the release book, the date is indicated, the date which the samples were received, the test is required, and then the person who compiled the forms. After all this is entered, another officer comes to check if what is entered is right. After it's checked and confirmed it's right, the date of release is indicated in the record book of release, then taken up to the secretary who receives the book, the release book with the forms, and then she signs that she has received the particular forms. She writes her name as the person who has received and then signs. After she receives them, now she forwards the forms. The release book comes back to the lab. The forms are forwarded to the head of the lab for comments. The head of the lab comments. After he comments, he returns them back to the secretary for typing. The secretary types. When she's through with the typing, she again uses the file to bring them back to the officer in charge of the lab to confirm if her typing is right. Then if her typing is right, the officer signs as the analyst. Then the report goes back to the head of the lab to do the final signature. Then the report is ready to be released to the customer.
I'm Jackson Kimori, Water Quality and Pollution Control Officer, Wrma. But currently I'm working here as a laboratory technologist. This laboratory is where we analyze water to verify its, or to try and understand its bacteriological or biological quality. So there are various tests that we do in this lab. The major ones are general coliforms. Okay, there is what used to be called fecal coliform, although currently now that is not a test. It is no longer practical in this lab because fecal coliforms are organisms that just withstand high temperatures, but there are other organisms that can withstand high temperature and grow, but they are not necessarily of fecal origin. So that's why in this lab currently we are not doing fecal coliforms, but we do what is called E. coli. Instead of doing that general thing called fecal coliform, we go direct to E. coli. So any water found to be containing both general coliform and E. coli is unfit for human consumption until that water is treated by disinfection using maybe chlorine or other means like ultraviolet rays. It can be treated through UV, it can be treated through filtration, or it can be subjected to those are the major ways of dealing with any water that is contaminated with those microorganisms. And these organisms are the ones referred as indicators of contamination. The organisms themselves are not dangerous to human being, but they indicate possible presence of disease-causing organisms. So the other test that we do here is residual chlorine. Residual chlorine means water has passed through treatment, it has been disinfected with using chlorine, but that water should still be having a small amount of free chlorine, and that is the chlorine that helps in preempting any contamination in distribution system. So when we do residual chlorine, we are trying to ascertain whether this water is still fit for human consumption, because if water has a small amount of free chlorine, 0.3 to 0.5, that water is good for consumption, because it's clear that that water is not contaminated with general chlorine. So the test that we have just performed, for example, is the one that we used to call, currently we are using a different method. Initially we was using what is called multiple tube fermentation technique, but that method is still good, but now currently we are using a more efficient and faster method, which we refer as defined substrate technique. And in what we have already done, we have taken a sample that was brought in the morning, stored in the fridge. The water should always be at low temperatures to avoid multiplication of these organisms. So that water we have removed from the fridge. We are supposed to cache a whole 100 ml. What we do in this method, we have a quantity which is quantity 2000. That one is able to cache 100 ml of water. Using, and the substrate used is this one here. It is referred as correlate. It has two nutrients or two substrates. It has a substrate called MAG, which supports the growth of E. coli, and another one called OMPG in short form, the one that supports the growth of coliforms organisms. So when you do this test, you are doing two tests at a go. You are identifying, or you are verifying the amount of general coliforms in water in 100 ml, and also E. coli in 100 ml. That means because this test is 18 to 24 hours, that means within that time you have quantified the concentration of general coliform in a sample of water and the concentration of E. coli in that sample. By doing so, you have shortened the time you are able to advise a customer, or we have shortened the time we are able to advise our customer, let's say water treatment facilities or water companies. We are able to tell the condition of their water within 24 hours or 18 hours instead of the 36 hours and sometimes 72 hours that we used to take in the older method. So currently we can say we are more efficient in our testing, and it takes only one day, 18 to 24 hours. So once this sample is poured, 100 ml into a quantity, then it is mixed with the substrate, the correlate. Once that correlate dissolves in that sample, is supposed to be sealed using a quantity sealer. This is a machine that will help us seal that quantity for incubation. And the incubation is at 35 to 37 degrees centigrade for that period, 18 to 24 hours. So once we are through with incubation, that is If you have done it today, you'll be reading tomorrow. You'll be able to quantify. We are able to quantify now the number of E. coli and general coliform if they were present. But if we find no change of color, if the water still remains clear, then it means there were the water was free, or the water is free from contamination. But if you discover the water has some yellow color, yellow coloration, then it means general coliform acted on OMPG, and the result is that complex, is that yellow complex. So you need now to lead by counting the number of big well and small wells in that quantity that are yellow in color. Then that one you get the concentration from the interpretation table. You'll be forced now from there, you cannot be able to know the number of E. coli without using this machine specifically. This is a UV generator. So the machine is referred as UV chamber. In this, we are able to read now to quantify the number of E. coli by counting any well, the big well and small wells that are going to fluoresce. Because once E. coli has acted on mark, the result is a bluish or a complex that fluoresces under UV. So once you put that quantity in this and you put it on, it is generating UV. All the trails, all the wells that are going to fluoresce, those ones are the ones you are going to count. You read the bigger wells against the small wells. And there you are able to go back to the interpretation table and they get the concentration of E. coli in cells, that is cells per 100 ml. And by so doing, now you have the result, a complete report of the bacteriological quality of a sample of water. So, of course, from there it's just the publication of the result in our form. And the result are ready for typing and signing on by the head of the laboratory for release to our clients.
Work in this wastewater as a water quality and pollution control officer. Basically, here we do a number of parameters. The one that I have presented is total suspended solids. In wastewater, we have total dissolved solids, we have total suspended solids, and what I have done demonstrated is total suspended solids. So the procedure for carrying out this: first we use filter papers, 45 mm size diameter, which we usually dry in the oven at a temperature of 125 before carrying out the filtration of the sample for a period of 1 hour. After 1 hour, the filter papers are dried in the desiccator for around 30 minutes. After cooling not dried but cooling in the desiccator for 30 minutes. After cooling, we weigh them in the weight balance in the scale of in grams in grams, in gram units. Then after getting the weight of the filter paper, this is when now you come with the sanction pump, which we use for filtration. And you take the sample, after inserting the filter paper in the central glass filtration system, you measure the volume of the sample. And in most cases, we consider how much of the volume, depending on the pollution, which you weigh by visual method. By visual method, it determines how much volume you're going to take. Then after taking the volume, you pour in the central glass and it is filtered into the main filtration chamber. After filtration, the filter paper is taken in the drying oven for another 1 hour. And after 1 hour, you cool it in the desiccator. And then after that, you weigh. Having gotten 2 weights, there is the weight of the filter paper without the sample, and there is the weight of the filter paper with the filtered sample. Out of the 2 weights, you are able to calculate the total suspended solid in that sample. And that is all we do with that process.
Welcome to the Central Water Testing Laboratories. My name is Kenneth Poride. I'm the Assistant Technical Coordination Manager in charge of the laboratory. Here in the laboratory, we specialize in water analysis. And in fact, we are the only national laboratory which focuses on water analysis. A brief history of the lab. The Central Water Testing Laboratory has been in existence for more than 3 decades now. It has been running under the Ministry of Water until 2011 when it was taken over by the Water Resources Management Authority. Currently we have more than 20 staff, half of who are technical staff specializing in water quality issues. The lab has grown over the years. When it used to receive less than 100 samples in a year, to currently over 3,000 samples annually. We as a lab, we receive samples from within the country and outside the country. Indeed, we receive samples as far as Somalia, Southern Sudan, and sometimes even Rwanda. So this shows that we are actually a regional laboratory. What activities do we do here in the lab, and what types of samples do we do? In the lab, we focus on a number of analyses. First, we do potable water analysis. In potable water analysis, we focus on the water samples which are targeted to human consumption, like drinking and other domestic purposes. There are different types of parameters which are analyzed in potable water, but normally we categorize them into 2. We have full chemical analysis and bacteriological analysis. Full chemical analysis focuses mainly on the physical-chemical characteristics of water to determine the chemical suitability of water for domestic use. While on the side of bacteriological analysis, we mainly focus on 2 bacteriological indicators, mainly the E. coli and total coliforms, because these ones are the approved indicators which are normally used to determine whether any type of water is suitable for drinking purposes. The other aspects of water which is analyzed here is environmental water, and this is a wide area of water samples. It focuses on water which is meant for research and maybe irrigation, other uses except domestic. The type of parameter which is analyzed for this type of water sample depends on the needs of a client. For example, if it is a research, then the researcher would come up with parameters which they want to be analyzed. If it is for the purposes of irrigation, then based on the need for that irrigation water, different parameters can be analyzed. But mostly they could be physical, chemical parameters, or bacteriological parameters. Another area is the wastewater samples, which we normally do for external clients and for the Wrma as institution. Here we do various parameters, mostly physical chemical parameters, but in some cases we also analyze bacteriological parameters. These samples are normally used for the purposes of monitoring the efficiencies of wastewater treatment plants, or for design of wastewater treatment plants, or for the purposes of compliance with regulatory requirements. For example, for discharges to get permits from Wrma or from Wrma, it is required that they submit laboratory results. So in such cases, then the Central Water Testing Lab comes in to help such clients get to know the quality of their effluents. We also carry out water treatment chemical analysis. These are chemicals which are used for water treatment. Normally, they are supplied by the water treatment companies or water service providers, who are the common customers. In this case, we help them determine the quality of the water treatment chemicals which they intend to use for their treatment processes. In some cases also, we help them determine the amount of chemicals which they would apply into their wastewater treatment, into their treatment processes to achieve the best quality of water. And finally, the other service is sampling. On request, since the lab has the expertise, we can help our customers sample their waters for laboratory analysis. This is more important when it comes to samples for bacteriological analysis, because such samples are quite sensitive and vulnerable to external contamination. So in that case, if a customer requests that we help them do their samples, we can also carry out such services. Generally, in our lab, we have a number of departments and a number of labs. First, we have the wastewater laboratory, which focuses on the analysis of wastewater samples. It is a well-equipped lab which is able to handle more than 10 parameters in wastewater, ranging from BOD or biological, chemical, oxygen demand, COD, which is the chemical oxygen demand, 4-permanganate, and the other parameters which are necessary for wastewater. Our second lab deals with bacteriological analysis. This is a lab which focuses on purely microorganism analysis. Though we normally analyze 2 bacteriological species which are E. coli and total coliforms, on request we can also venture into other macroinvertebrate analysis. Then our third lab deals with potable water analysis, and this is where we carry out full chemical analysis, or in certain cases specific parameter analysis depending on the customer needs. It is also the same lab where we carry out water treatment chemical analysis. Each of these labs is headed by a fully qualified laboratory analyst with vast experience in water analysis and pollution control. Now, who are our customers? The laboratory was set up to help the citizenry in knowing the quality of their water. So as a lab, we help the Water Resources Management Authority to fulfill its mandate in ensuring that water resources is protected in terms of quantity and quality. So our first customer is the Water Resources Management Authority. Our second customer is the local mwananchi. In this case, we receive samples for ordinary citizens who are willing or who are interested in knowing the quality of their water. So once somebody wants to know the quality of their water, they can get information from us through phone calls or emails or letters. Then we can help them on how they can bring their water samples for analysis. In case they also need other form of advice which may help them in determining the water quality they consume, we are also offering such services. And the other third customer are companies, especially the water service providers, whom we help in determining the quality of the treatment chemicals which they use for their water treatments, in determining the quantity of chemicals which they need to apply into their treatment plants to provide or to achieve the best water quality for the common mwananchi. What benefits do customers get from us? The first benefit is an efficiency. We understand the need for efficient service delivery to our customers, and therefore our focus is to offer efficient services to our customers. We have a dedicated staff who are always out to ensure that our customers receive the best services beyond their expectations. The second benefit to our customers is trust. Through experience, we have developed unrivaled reputation and integrity in the water sector as a laboratory of choice, and that is why we are one of the regional water laboratories in the Eastern Central Africa. In this case, we provide unbiased analytical solutions to our customers to assure that their products and processes meet the maximum required standards. Our customers will benefit from quality. Our lab is recognized by environmental and regulatory agencies, and therefore our results can be used for regulatory purposes. We ensure that the results achieve the best standards, not only nationally but also internationally. So in this case, we encourage more people, institutions to visit us for better services.